Okay, everyone. Welcome to our graduate open house from Loyola Marymount University. My name is Gustavo Bejarano. I'm an associate professor in the Department of Electrical and Computer Engineering. Today we have an agenda. We're going to present each of our graduate programs in the College of Science and Engineering. There are two programs that have separate sessions. Those are Healthcare Systems Engineering and Mathematics. So if you're interested in those programs, please make sure that you join the right session. So let's begin with introductions. Here in our session, we have several professors and our associate dean. I guess, Don, can you please introduce yourself?
Yeah, my name is Don Kendall. I'm the chair of the Civil and Environmental Engineering Department and also chair of the graduate program at LMU.
Thank you, Don. BJ?
Greetings, everyone. I am the director of the graduate program for computer science and a clinical assistant professor here at LMU.
Thank you, BJ. Omar? Omar, can you hear me?
Looks like Omar has audio problem.
Yes. Oh, Omar, you're muted.
Yeah,
there you
sorry,
go.
I'm having audio problems. Just give me a minute. I'm going to check the Bluetooth.
Okay. Nazmul, do you want to go ahead and introduce yourself?
Sure. Hi, everyone. Good evening, and thank you so much for joining our graduate open house. Hopefully, we'll be able to answer some of your questions. My name is Nazmul Ula. I'm a professor of electrical and computer engineering. I'm also the associate dean who looks after all engineering programs, undergraduate, graduate, both.
Thank you, Nazmul. Omar, did you fix the problem? Okay, well, I guess we're gonna wait. Anyways, we're gonna present each of our programs, so Omar will have an opportunity to introduce himself in a few minutes. Let me start with the presentation. First, in this presentation, we're gonna include the electrical engineering program, mechanical engineering, systems engineering, civil engineering, computer science, and the healthcare systems engineering is on a different session, as well as teaching mathematics. And today we're also presenting environmental science. The program options, we have different several programs. So we have MS programs in engineering from civil, mechanical, and electrical. We have MS. This is the degree. So Master of Science in Engineering. And over here we have a Master of Science only. That's a degree. And those degrees are in systems engineering, in environmental science, and computer science. We also offer a Master of Arts in Teaching Mathematics, and we have dual degree programs for an MS dual degree with an MBA. And those programs are, the dual degree program is available for all the previous programs, including environmental science. And we have certificate programs as well. Certificate programs are shorter in duration. Those are 3 courses only. And they allow you to get like if you're not sure if you want to join or you wanted to commit to the MS program, you want to test just a few courses, so you can do 3 courses for the certificate programs. And if you decide to continue, you're welcome to do so. And the 3 courses that you finish for the certificate program will count for your master's degree. So there are different funding opportunities for students. First we have assistantships. So these are graduate research assistantships. This is part-time employment with university. So this is mostly for students who are doing the programs full time. We have another group of students who are working professionals. So in those cases, the students may not have the time to do the work of an assistant. We also have range-rich assistantships. Those assistantships are also available to all students. And again, this is part-time employment with the university. Our faculty pursue grants from external organizations. If you're interested in working doing research with one of our faculty members, yeah, feel free to reach out to them and ask for any opportunities in that regard. There are scholarships. Scholarships are need-based. So if you are local, you need to complete your FAFSA. And if you're an international student, there's a separate procedure to do to apply for the scholarship. So yeah, the minimum requirement is that the GPA is 3.0, but the scholarships are on the basis of need-based, not academic performance. And then we also have teaching assistantships. These are also part-time employment with the university. And there are other types of financial aid, but if you're interested in that, you're welcome to contact the financial aid office. So our students are highly involved with professional organizations. So we have organizations from many of the different fields that we're presenting today. Yeah, this is the organization for all graduate students of LMU. And over here you have the professional organizations. So we have Engineering for Humanity, the American Society of Civil Engineers, American Society of Mechanical Engineers, the Institute of Electrical and Electronics Engineers, the Institute for Healthcare Improvement, International Council of Systems and Engineering, and we also have industrial partnerships with our industry partners. So yeah, we invite them regularly to come and talk to our students and do activities for our students. For each program, we have student awards. So these awards are on the basis of academic performance. So it's basically on your GPA. So we have an outstanding graduating student award and outstanding first year student. The outstanding first year student receives a scholarship. Campus resources. So there are many services that our students have access to. So international students, any questions related to visa and immigration can go to this office, the Office for International Students. There's the Academic Resource Center. I usually recommend students to go to the center to receive assistance on writing. Disabilities and support services, student psychological services, student health services, the library. This is a picture of a library. It has a very nice view all the way up to Malibu, what you see over there. So yeah, it's a really good place to go and study. And we have spiritual places. So there's campus ministry, there's our Muslim student life prayer room, and the chapel. This one in particular, I usually recommend students to go to our Career and Professional Development Center. They help you to prepare for interviews. They help you to finish your resume, and they also help you find internship and employment opportunities. So yeah, I always recommend students to go to that office. Then we have a place in our college where students can collaborate and do their work. So that's the room that you guys are seeing over here. It's the Collaborative Learning Center. And then there's the gym, the Burns Recreation Center. So yeah, students can go there and exercise. And there's a pool, which is really nice. So I don't want to take more of your time. I think we want to hear from each of our programs. So first, I want to go in alphabetical order. So perhaps we can start with civil engineering. So Don, please go ahead and present the program.
Thank you. So it looks like that's the screen showing. And so someone's going to operate those slides for me. Oops. let me go ahead and maybe I should share my screen, right?
Yeah, you can do that.
Okay, maybe that real quick. Okay, thank you, Gustavo. So the civil engineering and environmental science, our graduate programs have really three key areas that you see there. Traditionally, it's been water resources, environmental science, and environmental engineering. And we get an interesting mix of students, working professionals, students from different countries, local students who are perhaps full-time students, all interested in some aspect of these. And the point I want to make to you is that we really try to integrate this concept of sustainability in our coursework as you move along. So these are some of our recent grads at LMU just prior to the pandemic, and to show that we're a diverse group and small, and students just very excited with the program, very happy with the program. And I also think you would probably have a very good experience at LMU if you choose to come. So we have full-time faculty, been in LMU for quite some time. We have Rachel Adams, her expertise is in water quality. My expertise really is in water resources, statistical modeling, stochastic processes, hydrology. We have Jeremy Powell, specialty is really in climate change and sustainability. He's involved in running these large-scale climate models, which we all have access to, and as well as with research. Professor Joe Reichenberger, years of industry experience. He's been at LMU for many years and really spearheads our design efforts, both at the undergrad level and just practical experience as a professional engineer. So we're very happy to have him. And then Bill Trott, also in water resources and modeling. Now, we have part-time professors of practice. I might add that most of the professors that I just listed also consult in industry. And then we have professors that are full-time in industry. We have engineers from the Metropolitan Water District, water resources, water quality. We have professors in microbiology from the LA County Sanitation District. That'd be Professor Tim Haug, who's still with us, teaches an incredible course. Dennis Casper, recycled water desalination and membranes, LMU graduate, Caltech PhD, been in our program for many years. Mi-Huyen Park out of UCLA teaches our remote sensing as well as GIS. We have Frank Capone from Air Pollution Control District teaching our air quality class. And so you will get meaningful problems, and you'll be able to hit the ground running if this is a new area for you, because these are professionals that are teaching you. So as Gustavo mentioned earlier, we have a Master's of Science in Environmental Science, an ENVS degree. You can get a Master's of Science in Engineering. Typically, if you have a bachelor's degree in engineering, you can slide right into the Master's of Science in Engineering. And we emphasize, again, these three areas: water resources, environmental engineering emphasis. You also heard that we have these certificate programs, and that really started as an effort with the LA City Bureau of Engineering for their employees. Employees who weren't sure they wanted to take on a full master's degree, but wanted a certificate, which helped them professionally. And that's how that program started. And so we keep that going, and it's open to anyone who wants to become part of that. And the good news is, you can apply those courses to the master's degree if and when you decide to do that, or you can stop with a certificate. Right? So as again, I mentioned, sustainability is the central theme of most of our courses. We do have a dual degree program in civil engineering and an MBA. I guarantee you, if you're interested in that track, if you start early in this dual degree program, you will finish earlier, as opposed to trying to do them sequentially, one at a time. And so that's sort of the interest that some students have when they come to LMU. You do get 2 separate degrees out of the process. So in our program, we have core and required elective classes. Required classes we ask all our students to complete, and then we give them a choice with different electives that they might want to pursue. To qualify for graduation, you need 30 units with a 3.0 GPA, and specified core classes, which I'll show you here in a minute, and then the technical electives. And the electives are broad. They have a different range to allow the student to explore different opportunities they might be interested in. This is a recent trip some of our students had taken to Catalina to do some water quality sampling, and very active in that effort. You can do independent studies as an additional class. If you want to pursue your own topic of interest, it may be something that you want to do through your work, we can accommodate that. You get 3 units per course, and one of the faculty members would be glad to help you find that. And it's always an option for any student. So some students pursue that, and some don't. Many are happy with the programs that we have. So this is our climate model. I did that for Professor Powell because so much of what he has done in our department really revolves around all the climate work that he does. And so again, if you're not into this specifically, you could take a course in this area as a sort of a broad elective. Now, we also have thesis units. So many of our students actually write a thesis, mostly because they're going to go on for their PhDs, not all, but again, some topic that usually is tied to their work or tied to future graduate plans that they might be interested in. Now, when you're finished, we require all of our students to participate in an oral comprehensive exam. Exam is probably the wrong word. Is we actually give the students a choice of different projects that they could do some research on. It's a design problem of some type in engineering or environmental science, and we ask them to come up with a solution and then to present that solution to a group of professors. It's exciting for the student because they can focus on one area. It gives them a chance to improve their oral presentation skills and really delve deep into the subject. And the students that have gone through our program are very happy with this approach, and they feel it really ties in to their whole experience in the graduate program on showing up all of their knowledge that they had. And again, your ability to provide your basic knowledge is really what we're all about. And really, all the students do well in this, and it's a very congenial framework, collegial, and I would not perceive that as a high pressure environment. It's really an opportunity to really talk with you as a student and talk about some things. So that is something that's unique to our program. You don't see that in many other places, but I would tell you as a learning tool for you, it's quite valuable. Okay, these are just some of the other tidbits here. I won't go over each one of them. So I don't want to bore you with all these courses. We do have a PowerPoint which can make available to you, but we sort of highlight them in red, blue, and green in terms of the type of courses that you would take. Let's just go over some of the topics, right? So we have sustainable water quality and resources management, aquatic chemistry, surface water hydrology, groundwater hydrology, climate change and impacts. You get the idea. Water reuse, GIS use, remote sensing, air quality, urban coast, ecosystems. I mean, we really cover it all. We're very uniquely placed to do that. And so there really are topics that you will find quite useful. I'm going to talk to you a little bit later about what is this FE exam idea? What is that? And let me just briefly tell you that some of our students who come into the program as non-engineers or probably have environmental science backgrounds, but we do provide a pathway how they can get a master's degree in civil engineering. And they can do that if they can sit and pass the FE exam, which is a common exam, as your first step towards professional registration. Many of our students have done that, and they've kind of have switched from an environmental science track to civil engineering track, just depending on what their interests are or where they happen to be working. We meet fall, spring, and summer for our courses. So the opportunities you can get out of here in as little as 1 year. Most of our students take 2 years. If you're interested in the environmental engineering emphasis, it's the same idea. You'll notice over here we have core classes. Again, I'm not going to go through each one, but you see the general trend of the type of courses. We throw in environmental microbiology as one of the requirements. And then for the electives, you have quite a choice. I mean, it really is a complete choice in what you would see today in the practicing field of civil and environmental engineering. Environmental science, again, a slightly different bent. You can see now we're including aquatic chemistry, environmental microbiology, urban landscapes and ecosystem services, urban coasts, habitats, stressors, and resilience. You get the idea what they're trying to do with that program. And again, you still have this large choice of elective courses to take for your particular interest in program. Again, water resources engineering, same idea. Right? Now, let's say you want to be an environmental engineering program and you want to get out in 2 years. We will work with you, we'll lay out the process, and we start you in the fall, for example. In fall, spring, and summer, you would take courses, typically 2 courses a semester, 1 course during the summer. And if you follow along with that strategy, you'll be out in 2 years. Okay? Some students, I can't say many because this is a challenge, is they want to finish it in 1 year. It is possible to do that, but you can see you're taking 4 courses a semester, and it's a large load, particularly for graduate students. And but we can accommodate that if that's what you want. Again, this is on a PowerPoint that you can go back and peruse later as you want to look at the different courses. And of course, there'll be a time to answer questions. We've also laid out the track for the water resources engineering. Same idea. Can you get the flavor of the courses? We lay out a 2-year program for you, and then we have a 1-year program. Environmental science, same idea. Different types of courses taught by our professors, and the 2-year plan, and then of course the 1-year plan. Okay, so let me get back to this. Did I just lose you? Yeah.
You just muted yourself.
Great. Now I'm unmuted. Our students who have come into this program, many of them do not have an engineering background. I might have one, major in zoology, for example. We've had biology students who, for one reason or another, want to pursue an engineering career. And we try to find a pathway for them to do that. And again, as I've said before, the way you do that is you would have to enter in as an ENVS student, right? But if you can pass the fundamentals of engineering exam, and there's the website for it, and you can take an environmental emphasis, we will grant you a master's degree in civil engineering. And many of our students have used that to advance their careers professionally as practicing engineers. Now, they can't stop there. Ultimately, you would have to take the PE exam, which is an exam that all registered engineers take in the United States. California is no exception to that. So this FE exam is a 6-hour online exam, I think now. And our pass rate for the students has been quite good. And again, it's the first step towards becoming a licensed professional engineer. Some don't go that far. They stop with the FE. It just depends what their career interests might be. There are testing centers all around for you to take these. They're very accessible. And I understand now they're also going to make the PE exam all online. So it's really going to be very easy for students to find a testing location where they can get on a computer and take this thing online. That's one unique feature of our program that you're not going to see elsewhere. Now, even if you file for graduation and you haven't taken the FE exam yet, but you want that degree to say civil engineering, we can wait to process your diploma until you actually take that test. And we've done that for some students, you know, while they're trying to get all their other work done. Okay. Again, if you do switch to civil, of course, you would have taken the coursework to satisfy civil courses, right? And one of those emphases that we talked about, and that's not hard to do since there's a lot of overlap between our different electives. Thesis option. This is Brianna Pregana. Actually, worked with her on her thesis and working really with some climate models and studying drought. She went on later to get her PhD and is practicing now, I think still doing research. But we have the ability to do that with you. And the nice part about that, we have small faculty. And the faculty are interested in you as a student, right? So it's a different vibe for those of us who've been in larger universities getting our PhDs or even our masters. We have a different feel. It's very student focused, and so I think for many of you, you would probably find that very appealing. So several faculty will work with you. We usually on your committee, and in lieu of taking coursework, of course, you can take up to 2 3-unit courses and work on your thesis. Right? So that's for so many of our students very self-motivated to want to do that, and that works out quite well. If you do a thesis, you don't have to take the oral exam, which is really the oral presentation, because it's basically you're presenting your thesis work at the end anyway. So some of our research opportunities, just to give you an idea, in the environmental science world, you know, Rachel Adams works on pollutants in the aquatic environment. Jim Landry, environmental chemistry, studying metals in beyond wetlands, microplastics in the ocean, quite diverse look there for that. And then, of course, again, as I mentioned before, much of my work has been studying of modeling of drought, coupling that with stochastic models, coupling that with climate models and other techniques which we get involved with. If you want to look at that, Professor Powell, climate change, its impacts on water resources, hydrologic cycle, very active. He's an internationally known researcher. So we have the Bay Foundation. You might hear this come up again. And we do a lot of work with them. And so there's an opportunity to work with them. Some of the best grad students that I've worked with have been environmental science students who are working through that Bay Foundation. And we have Karina Johnson, who's part of that. We also have the Coastal Research Center at LMU. Same idea. There's an opportunity to get involved in real research that they're doing right now and have it be meaningful. And so that's also something very unique. We have the Center for Urban Resilience, And also the same idea, we can look at the environmental governance and green infrastructure through that program. So again, in this brief amount of time, I don't want to forget Professor Strauss, right? Dangerous species management, urban ecosystems. He teaches our biology for engineers class, even for our undergrads, very well known internationally. Now, what we have in our department is we have quite a large group of civil engineering alumni who are all practicing professional engineers. And they work with our undergrad and grad students in trying to help place them for potential jobs, mentoring them on how to write a resume, how to go through a job interview, basically connections for our students into industry. And so it's a service we provide to all of our students. And this is how many of them gotten their first jobs. And so we're very proud of the work that we do and continue to work with our students. And so it's the Council for Industry Partnerships. I won't belabor this anymore, but again, if you're not ready for an MS degree, you might want to think about a certificate. And here's the layout of the different certificates that are offered. We have a climate change solutions certificate, groundwater management certificate, sustainable development, health equity certificate, again, just sustainability, water and wastewater treatment certificate, water quality management certificate, and there's others that we're contemplating as we're moving forward. So I'll see our program is dynamic. As issues come up, professors typically respond to the issue and try to get information out to the student. Okay, so all our grad courses are in person. And of course, being post-pandemic, we also do record them for Zoom. And so we are taking advantage of that and plan to keep that as part of our choices for students if they can't get to campus all the time. So there is an opportunity there to do that. We're doing that right now in this semester. Most of our grad students like being in person. For our working professionals who are in downtown Los Angeles, it becomes harder for them to get here all the time. So this is an easier way for them to participate. And they seem to be happy with that right now. That's some of the feedback I've gotten from them. In any event, that completes my presentation. Again, my name is Don Kendall. There's my information. You can find me. And I believe we have a copy of this PowerPoint, which we can also provide to you. Okay, thank you.
Thank you, Don. So now let's go to the next program, computer science. BJ, whenever you're ready.
I am ready. I am sharing my screen and getting my presentation going here. Play from start. There we go. Okay, welcome everyone. My name is Robert Johnson. I usually go by BJ Johnson. I'm a clinical assistant professor in the computer science department here at LMU. I wanted to give you a presentation about the Masters of Science in Computer Science today. There are quite a few things that are in all the presentations, so I might skip a little bit on some of the things that are in some of my slides because they've already been covered. So I don't want you to think that I'm giving them short shrift. But without further ado then, let's go ahead and get started. Our degree requirements, all of our courses are 3 units each. As you can see here, the degree requires 10 courses, which is 30 semester units. A single credit hour or unit definition is 3 hours of work per week for a 15-week semester. Those are supervised by an instructor and represented in learning outcomes, verified by evidence of student achievement. So that's the formal definition for anyone that hasn't seen that yet. For our program, we have 2 required courses. We have a computability and complexity course and a programming language semantics course. Both of those are required courses at the 500 level. Then you can choose the other 8 courses that you'll be taking. 4 courses from either the 500 or the 600 level, and 4 courses that must be at the 600 level. So you can select from, for those courses, you can select from several different options. Just like the civil and environmental engineering, we have a thesis track as well as a capstone project track. So option 1 for us is to have 4 courses at the 600 level, possibly more, because you might take a second or a 5th course or a 6th course at the 600 level as one of your electives. But 4 courses at the 600 level, including your capstone project course. A second option would be to take 2 courses at the 600 level and a 2-semester master's thesis sequence. And the third option would be to take 1 course at 600 with a 3-semester master's thesis sequence. Okay, so those are the 3 options for how the courses can be made up. As you can see on the right side, I've given you a partial list of the courses that we offer. This is some samples of the electives. Not all courses are offered every semester, but you can see a good sample here of some of the more popular courses that our students like. We have a course in embedded systems. We have machine learning, for example, natural language processing, courses in software architecture and agile development. Those are good for learning project management and how to actually construct software. We have database systems and artificial intelligence, cognitive systems and deep learning applications. So these are just a few of not even half of the courses that we have on tap. Here is one way to put this together. This is kind of a 2-3-3-2 approach. Just like the civil environmental engineering sequence, you could also do 2-2-1, 2-2-1 and be out in 2 years. So, but for example, you could take your computability and complexity in the first year and then either a 500 or 600 level elective. Second year, you could take your, or I'm sorry, second semester, you could take your programming language semantics requirement, and then another 500 or 600, as well as a 600 elective. The 600 elective could be in the summer. Either one of those actually could be in the summer. Third semester, again, you could either double up or take only 2 classes, but again, a 500 or 600 level and a couple of 600s. This might be for maybe doing a, if you're into computing complexity, or if you're into cyber type stuff, like cybersecurity, those kinds of things. Those are courses that are offered, it might be in the summer, but also in the fall. And then your 4th semester would finish up whatever you need, and followed by the capstone project. Okay, so that would finish out your 10 courses. For our course management systems, we usually use a tool called Brightspace. Here are a couple of the pages, web pages. This is a web-based tool, and you can see across the top all the different tabs that are available, so that you can actually access content, any quizzes or exams that are in there. There's a forum that you can actually discuss things, or actually talk back and forth with other students in the class. If you are working on a project in a group, there are groups that you can join in Brightspace. So you can see this is a very flexible and useful tool for managing your coursework. In terms of the non-thesis option, the Graduate Capstone Project, this is actually a project that you make up. You do something that you want to work on. You work with a faculty advisor that would be a person of your choice. So you might end up working with someone that you have taken a course with, who says, you know, I'm really interested in this, and I think it looks like you might enjoy working with me on this. It might be the situation where you develop an interest and you go to some other professor in the department and say, I would like to work on this. Would you be my advisor? So either way, there's a flexible combination there, a flexible collaboration that can result from that. The students select, research, write about, and then present over the course of the semester some subject of current interest. For the Capstone Project, you will also need to attend at least one professional meeting from a local chapter of one of the professional organizations. Fortunately, there are, in Los Angeles, there are quite a few of those. So the ACM and the IEEE are two of the main ones, but there are several other professional organizations that you can attend. And the presentation that you do at the end of the course is a presentation to faculty members. So as you can see, you will do a presentation, a formal presentation to the faculty members from the department and from other departments as well. Actually, you can see in the left slide, this is an electrical engineering panel. So we've got 4 professors in the audience that are electrical or systems engineers. The master's thesis, students may enroll in up to a maximum of 3 semester hours of master thesis in any given semester, up to a maximum of 9 semester hours for the degree. Students electing the thesis option must obtain a thesis advisor before the departmental consent can be given. And it has to conform to the College of Science and Engineering requirements, which are stated. You can find that on the Seaver website. Students are expected to publish the thesis work in some sort of a national or international conference proceedings or in a journal. Here are a few of the past publications that have been presented from the master's thesis program. So as you can see, it's a pretty good selection here. Quite proud of that. Some of the course projects for the 694 capstone projects are shown in some of these slides. We have causal inference from cognitive systems. We also have GreenSight, which is an ongoing collaboration between computer science and biology, which is for representing genomes in a web browser. We also have game design and virtual environments. The top slides show some of the research that's been done using virtual environments in a tool called Second Life. Autonomous drone systems, as you can see, including a drone that can actually dunk a basketball. Drone swarms, as you see on the left of the bottom. We have deep learning and machine learning projects. We had one project, as you see on the top right, where 3 students actually built a pothole detection system that would detect potholes and film them in terms of, and also record the location of where they were located. We also have software-defined radio. We actually have a working satellite program called CubeSat. Very small, I think they're 10 centimeters cubed, that are actually working satellites. We have a ground station on campus that is up and receiving signals from the Oceanographic Institute. We have green energy projects that have been done. As you see here, we've got a wind turbine model. We have antenna design. And as you can see again on this is a rooftop antenna we have on the bottom, on the top of Pereira South. The admission and application requirements, all applicants must possess a bachelor's degree in computer science, mathematics, or some other closely related field, such as systems engineering or electrical engineering, computer engineering, or something other that is related to computer science. Undergraduate preparation of all applicants, regardless of their previous degrees, should include some of the following subject areas: computer programming, of course, a data structures class, a computer systems organization class, and at least one of the following four: microprocessors, languages and automata, or operating systems, or database systems. Okay. You need a completed application form and a $50 application fee. You'll need 2 official transcripts from all schools attended since high school. You'll need a letter of intent, and optionally 2 letters of recommendation, and optionally you need to take the GRE. Those last 2 though are optional. Okay. We also have a dual degree program with the Master's in Business Administration from the Business School. Students enrolled are jointly advised by program directors of both me, the MSCS, and the MBA programs. You first enroll, and when you want to go this track, you first enroll in the MS program in the MS2 Computer Science, complete 12 units of the program with a GPA of at least 3.0, and then you can join the MBA program. So you get a little bit of a break on the computer science end of it with this, because you only need to complete 24 units of computer science courses instead of 30. However, the other 6 units get tacked on to the MBA. So you will still need to end up taking a total of 60 units. But at that time, you get a dual degree. We do also have 2 certificate programs. It's usually 2 to 3 semesters, but it might be actually a little shorter than that, depending on how many classes you take during a semester. And again, these it's not really easy to cram 3 courses into one semester, but you can do it. But there's a software architecture certificate and there's a cybersecurity certificate. So you can see the required courses for each of those certificates. And just like the other courses were mentioned, or the other programs mentioned, if you decide to take the certificate program and then decide to stay on and get the full master's, all of the courses that you've taken at the certificate as part of the certificate program will count towards your master's. I won't go through all of this because this is the same thing that Dr. Bejarano said in his opening slide set. But yes, we have lots of opportunities for financial aid. The Career and Professional Development Office, as he mentioned, is very helpful for all kinds of things to help you with your professional career. Some of the things, in addition to what Dr. Bejarano mentioned, is that they have career coaches that will conduct mock interviews with you so that you get practice doing interviews. Can help you with your networking strategy. How do I talk to people in the industry? We have a tool that maybe many of you are familiar with already called Handshake, which helps you with job searches and to track opportunities of interest, monitor recruiting activities, all those kinds of things. We have the CPD presents career expos, a couple or 3 times a year, so that there are lots of opportunities for outside companies to come in and recruit. There are grant awards for students. There are unpaid and paid internships. And some of the companies that our graduates have gone on to work for are listed over on the right here. So you can see there's some pretty high power companies here: Raytheon, Boeing, AT&T, Google, Amazon, Intel, SpaceX. So there are some pretty high power companies that hire our graduates. Sometimes when you're on campus, and most of our classes are still in person, we do record most of them and post the recordings on Brightspace so that you can watch them offline. But most of our classes being on campus, sometimes you just need to go find a nice quiet spot to just relax. And here are some of them on our campus. As you can see, there are beautiful views, well-shaded green areas, water all over the place that sounds nice in the Shea Terrace. So there are quite a few spaces here that are very peaceful and relaxing. And that's my presentation. That's my smile. Here's my information. Please feel free to get in touch with me if you have any questions or need any further information. And I look forward to talking with you soon. Thank you for joining us today.
Thank you, PJ. The next program on the agenda is electrical engineering. And I'm glad to present the program. I'm the program director for electrical engineering. So let me share my screen and then we'll start. So yeah, so before I give you the presentation, I wanna let everyone know that the Department of Electrical Engineering used to be the same Department of Electrical and Engineering and Computer Science. So many of the activities that Dr. Johnson just presented are in collaboration between electrical engineering and computer science. So some of the content of this presentation overlaps the content of Dr. Johnson. So I may skip those slides just to for the sake of saving time. So here are the degree requirements of the MS in electrical engineering. So as any other program, students have to complete 30 units to graduate. And remember that 1 unit is 3 hours of work per week. There are a number of required courses. So those are the courses that you are seeing over here. Okay, so you need to complete computer architecture with VHDL, radio frequency engineering and antennas, and random processes. Notice that each course is 4 units. Okay, so that's something different about this program with respect to the other ones. Then you need to complete an elective course within electrical engineering. The elective courses, we have sample elective courses listed over here. So for example, it could be optical engineering, wireless networks, digital image processing, and so on. Then students have to select one of 2 options. Students can select either a capstone project or a thesis. The capstone project over here. So first you need to complete another elective, another electrical engineering elective, and then 4 units of capstone project. That would be this course and this one. Now this one is of 2 units and 2 units. So we broke the capstone project into 2 courses of 2 units each. This is to give more flexibility to the program. So you can complete the capstone project in either 1 semester. That means you could register 4 units, or you can complete the capstone project in 2 semesters. You do 2 units in semester 1 and 2 units in semester 2. The reason why I give this flexibility is because many of our students are working professionals, and they may need more time to complete their capstone project. Other students are full-time students. Most of them are international students, and in that case, I would recommend that they finish the capstone project in 1 semester. Then, so that's a total of 24 units. And then students have to complete another 6 units of elective courses. Now, those 6 units may be in electrical engineering courses or courses outside electrical engineering. Common choices include systems engineering and computer science, but students are welcome to consider courses of mechanical engineering, civil engineering, environmental science, and so on, provided that they have the prerequisites for those courses, right? So once you're admitted into the program, you're gonna meet with an academic advisor. I will be your academic advisor if you become a student of electrical engineering. The role of the academic advisor is to meet with a student every semester to go over the study plan. The study plan is the list of courses that the student is going to complete until graduation. Now, the plan is not a contract. You can make changes to the plan as you move forward with your semesters. So here's a sample study plan. This study plan is the most common one. Students complete the program in 4 semesters. So this is basically 2 calendar years. So in semester 1, students can complete over here 8 units. Those are 1 course that is required and an elective course. Then students can take in the next semester, they can take another 8 units over here of 2 courses that are required. And then in semester 3, students can take care of elective courses. So this is a total of 8 units. And then in semester 4, students can do the Capstone project over here. So remember the Capstone project is broken into 2 courses, but you can complete both courses in the same semester. If you want to complete the program in a shorter time, let's say in 3 semesters, then the study plan can be revised and you can move this course to semester 1, you can move this course to semester 2, and you can move the last course to semester 3, and that will allow you to complete the program in 3 semesters. Okay, yeah, so that's the study plan, and yeah, you meet with your advisor every semester to make sure that you're making progress towards graduation. As Dr. Johnson mentioned, our courses are offered in person, but there are online components of our courses. So the platform that we use is called Brightspace, and instructors make all course materials available in Brightspace. So we include the recordings of the lectures, PowerPoint presentation of the lectures, homework assignments, and so on. As I was telling you, students select one of 2 options. One of them is the Capstone Project option, and the other one is the Thesis option. So what you're seeing over here is the Capstone Project option. Remember, the Capstone Project can be completed in 1 semester, and you're gonna work with a faculty advisor. So with your Capstone advisor, the Capstone advisor can be any of our faculty members. So you could do, let's say, if you're interested in working in antennas, then you can go ahead and talk to that professor. If you're working on wireless networks or drones, then you would come and talk to me. So yeah, so depending on the topic of interest, you reach out to any of our professors, and they will be more than happy to supervise your project. On the thesis option is, you can think of it as a longer Capstone project. You need to complete it in a minimum of 2 semesters and a maximum of 4 semesters. Remember that we're giving flexibility on how long you take to complete the thesis or the Capstone project. It is expected that you make an original contribution, so it is expected that our students publish their work at peer-reviewed conferences and journals. So yeah, what you're seeing over here is a sample list of the venues where students have published their work in the past. There's a dual degree program. Remember that this option is available for all programs, so you can do the MS in electrical engineering along with the MBA program. In that case, you need to complete 60 units total, okay? That is 24 units of electrical engineering and 36 units of MBA. It's this, okay? If you're interested in this, you don't have to apply to this directly, because first you need to complete 12 units of electrical engineering. By the time you complete those 12 units, you may consider applying to the dual degree program. And then over here, I have a sequence of slides with the areas that our faculty and students are working on. These are the same slides that Dr. Johnson presented a moment ago. So I'm just going to go over them quickly. So yeah, students can do work on cognitive systems, bioinformatics, game design and architecture, autonomous drone systems, ultra-fast imaging and remote sensing, wireless sensor networks and the Internet of Things, on deep learning and machine learning, on software-defined radio and CubeSats, on green energy, antenna design, motion capture systems, and yeah, so those are the most recent areas that students and faculty are working on. Okay, so if you want to apply to the program, well, you need to have a bachelor's degree in electrical engineering, computer engineering, or another closely related field. We will have to make sure that you have these courses before you apply. If we don't see all of those courses in your transcript, let's say that you're missing, let's say, electromagnetics, then we're gonna add that course to your study plan. It will be an extra course that you will need to complete to graduate. To apply, there's an application fee of $50. You need to submit your official transcripts. If you are an international student, you need to submit an evaluation of your transcript. You need to submit a letter of intent. It is 1 to 2 pages. We want to know about the accomplishments that you've made so far. So if you're coming straight from an undergraduate degree, we want to know what kind of projects you did as an undergrad student. And if you're a working professional, we want to know about your responsibilities in your job. On the same document, you should also address why you're trying to pursue this program and what your plans are after graduation. These items are optional, so letters of recommendation are optional, and the GRE is also optional. The minimum required GPA for admission is 3.0. However, if you have work experience, let's say that you have a GPA of 2.9, if you have work experience and you have good letters of recommendation, we can consider that as evidence of good performance in our program. So basically, we want to admit students who we are confident are going to do well in our courses. Financial aid, I mentioned the financial aid that's available at the beginning of our meeting today. So perhaps I can skip that slide. There's the Korean Professional Development Center. I think Dr. Vijay gave a very good description of their services. And again, this is for helping you to find employment, and they connect you with companies. They go and visit companies, and they help you find opportunities for employment. Here's my contact information. Feel free to contact me. I'll be glad to share the presentation slides. And thank you for coming today. So let me exit this presentation. And let me take a look at what's next on the agenda. So give me 1 second. So the next program is going to be mechanical engineering and then systems engineering. That's going to be the end of our meeting today. So let's proceed with mechanical engineering. And Dr. Esaid is the program director.
Thank you, my friend Gustavo. Emily, can you help me please with the slides? Thank you. Sorry, I don't know why my computer today doesn't want to open any PowerPoint presentation. Anyway, my name is Omar Said, and I've been teaching at LMU for the last 36 years. And I'm the current director of the graduate program. Next one, please. The goals of the program is to serve engineers to advance their careers in industry. We have modern, professionally rigorous and convenient program. Like, for example, we don't ask you to take some courses as obligatory courses. Only one obligatory course is a mathematics for engineers class, and then the rest you can pick and choose with things which are important for you or things which you like to work on. And the program is very flexible. Our classes are from 6:30 to 9:30 at night. So if you're working in industry, you still have time to come and take the classes in person. Thank you. Next one, please. There is strong emphasis on industry relevance. And for example, for myself, I've been consulting for the Navy since 1994. And several professors have strong contacts with industry. And most importantly, we have several professors from like Northrop Grumman and Jet Propulsion Laboratory and other places where they come and they teach areas that they are strong in. And we have small class sizes. Like, for example, this year, the biggest class I'm having is having 19 students, and most classes have less than that. So students can interact with the professor. It's not like big universities that you're only working with teaching assistants. It is a really working with the professor directly. And the faculty members have extensive industry experience other than those that we invite from industry itself to come and teach classes. Next one, please. The admission requirements, if you do not have a bachelor's in mechanical engineering, then you have to take 5 classes in the undergraduate level, which will not count into your graduate degree. Mechanics of materials, dynamics, thermodynamics, fluid mechanics, and heat transfer. Then you can take the graduate classes, which will be counted in your degree. Thank you. Next one, please. The program requirements is 10 classes or 10 hours with a total of 30 semester hours. Only one class is required, is obligatory, MEC 604 engineering math. The rest, you can take classes in 500 and 600 level classes. 4 of these 9 have to be in 600 level. And you have the choice of taking an elective in another engineering department. Our students like to take them in systems engineering, but you can take them in civil engineering or electrical engineering as well. There is a thesis option, which I will be talking about a little bit more later, which counts as 2 600 level courses. So if you are supposed to take 4 600 level classes, if you do a thesis, you take away 2 600 level classes out of them. Thank you. Next one, please, Emily. If you are from LMU, and this slide is only private to LMU, you take 1 less class because they take 500 level classes in their senior year. So this means that they're going to take 9 graduate classes beyond the BS degree that they are having. Thank you, Emily. Next one, please. Now, the faculty members are having diversified areas of their expertise. Rapid prototyping and 3D printing, Dr. Rafiq Nourani. Biomedical engineering, Dr. Brendan Smith. Design and manufacturing, Dr. Matt Sinowski. Renewable energy, Dr. Emin Isakian. Material science and engineering, myself. And also dynamic systems and controls, Dr. Smith. And flow physics and aerodynamics, Dr. Emin Isakian. So we are covering the broad areas of mechanical engineering. Next one, please. To graduate, you need to maintain a cumulative GPA of 3.0 and above for all classes. And a maximum of 4 courses may be taken in any given semester. We do not encourage that any student would take even the 4, although sometimes they do it, because it will become really very hectic. But according to the rules, you can take up to 4 courses in a given semester. And if a student is interested in taking a thesis, the prospective student should meet with me and discuss it. Next one, please. Now, our faculty members not only supervise these theses, but we also encourage the students to publish them. For example, for me this semester, I'm having 2 graduate students doing their MS theses. One of them is Mark Sanga. He's doing his graduate thesis in 3D printed titanium, 6 aluminum, 4 vanadium. The thesis have been provided by Jet Propulsion Laboratory, and Dr. Tent from JPL is the co-advisor, and the work is on fatigue of this 3D printed titanium. The second thesis is by Ivan Del Castello, and he's working on 3D printed aluminum silicon tin magnesium. Components made up of this material are installed in aircraft and in automobiles and. So he is monitoring the effect of the thermal exposure on the integrity and mechanical properties of this material. A collaborator with us is Dr. Alan Wilson from Boeing. They provided the project and they are supervising it with us. And Dr. Brandon Smith is supervising another thesis this semester. And we expect in the coming semesters that other theses are going to be supervised. This is, for example, a publication from Dr. Brandon Smith with one of his graduate students. Next one, please. This is a publication again by Dr. Smith with one of his graduate students. Next one, please. Dr. Matt Sinowski, and these are publications with his graduate students. Next one, please. And Dr. Matt Sinowski again with other graduate students. And Dr. Isakian with one of his graduate students. Next one, please. And Dr. Nourani with his graduate students. Next one, please. And again, Dr. Nourani with his graduate students. Next one, please. And Dr. Masha Ibrahim. Next one, please. And also Dr. Masa Ibrahim. Next one, please. And these are my students in their publications. For example, the Journal of Materials Engineering and Performance has an impact factor of 1.8 plus. So these are refereed journals, and the students, when they publish their work, they put their names with people from industry. Like in the first publication, the Weiser and Niji and Battelle are from MOOC. And in the second publication, Dr. Mark Timko is from Weber Metals. Next one, please. And in here again, Dr. Mark Timko from Weber. And in the last one, Dr. Michael Hahn from Northrop Grumman. So as you see, we encourage research and publications. We have in the mechanical engineering department over 60 pieces of equipment, small and large, and we make them operate all the time. And we do encourage that our students will go later to do PhDs, or that they have a good component of research when they go to industry and carry on their work in industry. Next one, please. And this is my information, my phone number and my email, and I will be very happy to take any questions. Thank you, Emily, my friend.
Okay, Professor Omar.
Yes.
Okay, please, I would like to know if there is currently an ongoing research in energy materials at your department.
In aging materials?
Yes, please.
No, but I did. I mean, with all humbleness, I had lots of publications, and I worked on aging. Are you talking about aluminum alloys?
I think he said energy materials. He typed it, or it was typed in the chat.
Oh, energy, not aging. I'm sorry.
It's okay.
No, we are not doing anything on energy materials. However, if this is something which you would like to work with, I can help you and I can work with you on it. I have the background and the expertise to work with you on it.
Okay, thank you very much.
Thank you. Sorry, I didn't understand the question.
Thank you. Thank you, Omar.
Thank you.
So we have one last presentation. This is for the systems engineering program. I'm glad to present the program. I'm the director of the systems engineering program. The program offers a flexible curriculum that is based on 3 areas. So students have to complete a systems engineering core, which is 3 courses. Then an engineering project management core, which is another 3 courses, and then a technical elective. The technical elective can be any of this. So the technical elective can be systems engineering itself, or engineering management, electrical engineering, mechanical engineering, computer science, civil engineering, cybersecurity, software architecture, and aeronautics and space systems. And then students have to complete a capstone project in their last semester. The faculty of this program are experienced professionals. The vast majority of faculty on this program are working professionals. So here I want to tell you a little bit more about the different areas. So the systems engineering core has 1 course that is required, systems engineering, and then students have to complete 2 courses that are elective. Those are sample elective courses. So that could be systems architecting, advanced systems engineering. Now, moving on to the project management core, there's 1 course that is required, project management, and then students have to complete 2 electives from this set. Now, this is a sample set. This is not the complete list of electives. And then students have to select one of the technical focus. And then in the last semester, students complete the Capstone project. As usual, students have to meet with the academic advisor to come up with a study plan. This is a study plan of a student who graduated in spring 2020. Let's count how many semesters a student took to graduate. So this is 1, 2, 3, 4, 5, 6. So the student took 6 semesters to graduate. This is the usual case for working professionals. If you are a full-time student or an international student, you should be able to take more courses per semester to complete the program faster. This slide is showing the courses being offered in spring 2022. So if you're admitted into this program, you're going to select courses out of this list. So yeah, keep in mind that we have a long list of courses within the program, but not all of them are offered every semester. We offer a subset of the courses every semester. So this is the set of courses that are being offered in spring 2022. So you would start with project management, which is one of the required courses, and then you could take perhaps 1 or 2 electives. So there could be agile development, case studies in cyber defense, engineering, economics and finance, advanced systems engineering, systems architecture, software architecture, secure software development, and systems engineering modeling and analysis. When students reach their last semester, they have to complete a capstone project. The capstone project is usually a collaboration with industry, perhaps the employer of the student if the student is working. Sometimes students volunteer for organizations. So here I just wanted to mention 2 sample capstone projects. Chasen graduated last year, and he works for Raytheon, and his capstone project was related to his work. He wanted to do some safety analysis on a radar laboratory at Raytheon. And then Joshua also graduated last year, and in his case, he volunteered for an organization, and it's a food bank, which had some problems during the pandemic because the demand for their services spiked. So he helped them scale their services to handle more food, and they also provide medical services. So he was looking into this problem from a systems engineering perspective, and he helped optimize their operations to be able to attend to more people in need. There's a dual degree program, like in the previous cases. You have to complete 12 units of the systems engineering program with a GPA of 3.0 to apply to the dual degree program. And in that case, you will complete 60 units. Okay, that's twice the number of units. If you do the MS program only, you will complete 30 units. There are certificate programs. These are 3 courses. So this is in case you're not sure you want to commit to the MS program, so you can complete 3 courses, and then if you decide to stay, those 3 courses may count for your MS degree. The certificate programs are in systems engineering, engineering project management, cybersecurity, software architecture, and aeronautics and space systems. This is a table that shows how students can benefit from the tuition assistance from their employers. So basically here I'm just I came up with this table to quantify how much you have to pay from your own pocket if you're receiving $10,000 per year from your employer. So yeah, in this case, for this case, you would take 2 courses, and in the end, you would pay 32% out of your own pocket. The best option is this one, in which you only have to pay 12% from your own pocket. And so yeah, here's the number of courses that you will need to register per semester to get that benefit. This is it for today. Here's my contact information. Feel free to contact me if you want information about any of the programs. And I guess for now we can take any of your questions. Well, I guess Emily did a fantastic job answering questions in the chat, and we don't have any questions at this moment. So again, thank you everyone for coming. Thank you all to the all program directors, and Emily, thank you for putting all this together. Bye everyone.
Thank you, Gustavo. Thank you, Emily. Thank you, Nazmul.
Thank you all so much.